Hi folks, Mr. Comer here. My tie doesn't go with my shirt, but that doesn't matter because it's quarantine. First, a few students asked why in the previous experiment we placed one piece of tape by itself and then the other two pieces of tape on top of one another. Hopefully now that you've watched the video, Dr. Samara did a pretty good job of explaining why this was the case. What we did was create two pieces of tape that had a negative charge and one piece of tape that had a positive charge. When you did the experiment, you should have been able to see that the two pieces of tape that were attracted to one another must have had different charges. And whenever the pieces of tape repelled one another, they must have had the same charge, right? Remember that inside of electromagnetism, like repels like and opposites attract. So a negative and a positive will pull closer to one another, and two positives will push away in a similar way to two negatives. Okay, so with what we talked about in my previous video and with what you saw with Dr. Samara, I'd like you to witness the following three experiments. After you do, I want you to answer the questions that are attached in this assignment. I want you to tell me why I set up the experiment the way I did. I'm going to be very specific about the materials that I say I'm using in these. You should tell me why the material choice is important. If you swapped it out with a different material, would it necessarily work? Also, I want you to tell me what you think is happening in each experiment, and I want you to use the vocabulary that we've been using so far. So negative charge, positive charge, polarization, contact, friction, induction. All of these were things that we talked about in either my video or Dr. Samara's video. So if you're at a loss, if you're like, I'm not sure what these mean, yeah, you can Google them, but I would also just watch Dr. Samara's video again or try mine. I think it will do a little bit better of a job saying, okay, I see the animation showing what induction is, therefore I think induction is going on in one of these experiments. Remember, just do your best, not expecting perfection, okay? All right, so with that in mind, I'd like to explain to you the very first experiment that I'm going to run. This is actually something that's rather famous. It was created by Benjamin Franklin some time ago when he was doing his experiments with electricity. Okay, so first I'm going to take some plastic cup bottoms, cup lids. These are plastic, okay, and I'm going to put them here to be my kind of centerpieces. Okay, all right, now I've got these metal cans, okay. Put one metal can here and one metal can here. Delightful. Hopefully you're able to see both of those. Now, I've already created this next piece that I'm going to add to the center here, but let me explain it a little bit. I have a pen. I specifically chose one that was plastic with no metal in it. This is just the plastic outside, okay? I've also got this string, just a bit of cotton string, which is taped onto here and from which is hanging a aluminum foil ball. Perfect. Okay. I'm going to set these up so that the ball is relatively close to both of these cans, and I'm going to wait for the thing to stop swinging. So I'll be right back when that happens. And we're back. The two cans are properly spaced. The aluminum ball is in the center of the two of them, and it's not moving. You might see it squiggling back and forth a little bit. That's just because of the air current from the window open in my room. It's pretty much not moving. Okay, now let me gather the last couple pieces I need. This is polyvinyl chloride, aka PVC piping. It's probably what carries most of the water in your house. And PanCat is going to give me a scarf that he was wearing. And I'm going to use this scarf, which is made of cloth, to rub it on the PVC piping. Now, I don't know if you can hear this. I'm going to hold this near my mic for a second. You might be able to hear some light crackling and popping going on. That's static electricity. I'm generating it by rubbing it against this PVC chloride pipe. All right, now I'm going to hold it near one of the cans. I wonder what's happening here. You'll tell me. Oh, cherry Coca-Cola. Here's a cherry Coca-Cola can. I'm going to put it on my mat right here. I promise I have not been paid by the Coca-Cola company. This is not product placement. Really, you should probably drink less soda as is. I've seen some of those Monster Energy drinks you guys put back. Anyways, here's our old friend PVC pipe. And where'd you put the scarf? Oh, okay. Here we go. And we've got our scarf. Now, we're going to once again rub the PVC pipe with the scarf. I can hear the snapping, I can hear the crackling of static electricity building up. By the way, I've posted the Triboelectric series on this, so you should be able to look at the Triboelectric series, look at cloth scarf, and look at PVC pipe, and tell me which one is becoming positive and which one is becoming negative, okay? Now that that's done, I'm going to take the PVC pipe and hold it near the metal can. Oh, well, that's interesting. Very interesting. What's happening with this metal can and the PVC piping? Okay, as you can see here, folks, I've ripped up a bunch of small bits of paper. There we go. Nice. PVC pipe, scarf. Once again, I rub the scarf on the PVC piping. Smell that? Smells like PVC piping off-gassing. I bet that's probably great for my lungs. Okay, we're going to hold this near the paper and see what happens. Well, interesting. Seeing many bits of paper jump up and drag themselves towards the PVC piping. Interestingly enough, though, some of them seem to be dancing away. In the end, I had 3 or 4 pieces that are stuck to the PVC pipe. Let's do that one more time. Move the PVC piping along, and we've got some bits and pieces that are jumping up and slamming themselves onto the PVC piping. You can see some of them on the bottom here. Interesting. Tell me what's going on. All right, folks. So again, the assignment for today is to take a look at those 3 experiments I just did and answer the questions that I've attached to this assignment. If you have some PVC piping around your house and you have some cloth, wool, something like that, that you would like to try either the same experiments or something similar, please feel free. The bell right here that we call a Franklin bell is also fairly easy to perform at your house if you would like to give that a try. Again, if you're stuck on some of the vocabulary, like you're not sure which one of these was induction, which one of these was contact by friction, this, by the way, contact by friction, take a look at the Crash Course Physics video. Again, Dr. Samara does a very good job of explaining those concepts with some animations to make it a bit easier. Okay, today I'm going to leave you with a question one of the students asked: why on earth am I collecting moss? Well, I am a big fan of terrariums, so I have been trying to make my own little terrariums in the house with some old glass bottles and things that I have around, and I've been out collecting moss. I'm a very big fan of moss. Be well and be safe, everybody.
Thread moss. Hair cap moss, one of my favorites. Hypnum moss, very good. Excellent. Star moss.